Good morning, children. How are you all? I hope that you all are fit and fine. Okay. In the previous classes, we have seen about Newton's laws. Okay. Newton's first law, Newton's second law, and the discussions of all the laws. Okay. Yes. Today's class, we are going to see the application of Newton's law. Okay. We are going to see about the application of Newton's law. Okay. Are you ready? Take your physics book, take a note, pencil, okay, pen with you. Okay, let's start today's class. Now, first of all, the first application is free body diagram. Okay, what is free body diagram? Okay, it is a simple tool. Okay, it is a simple tool which is used for analyzing the motion of the object. You understood? It is a simple tool which is used for analyzing the motion of the object.
It is moving like that. Okay. Analyzing the motion of the object. The systematic steps are followed for developing a free body. Some procedure is there for developing the free body. First of all, what we have to do, we have to find, okay, or object எடுத்துக்கோங்க. First of all, we have to find what are the forces acting on the object. You have to identify the forces acting on the object. Second, you have to represent the object as a point. Represent the object as a point. Third, draw the vectors representing the forces. Okay, according to the forces, you have to draw the vectors. Draw the vectors according to the forces. Do you understood? So, when we draw the free body diagram for an object or a system, the forces exerted by the object should not be included in the free body diagram. Do you understood? When we draw the free body diagram for an object or a system, forces exerted by the object should not be included in the free body diagram. Okay. There are some problems based upon the free body diagram. Okay. Suppose a book of mass m. Okay. Book of mass m is at rest on the table. First of all, you have to find three. Okay. You have to find three steps. First, you have to find what are the forces acting on the book. Second, what are the forces exerted by the book. Third, you have to draw the free body diagram for the book. See in the picture, in an object, there is a force which is normal and a force which is gravitational force, and this applied force is there, frictional force is there. So, your force diagram, which is also known as a free body diagram, is a sketch in which all the force vectors acting on an object are drawn with their initial points at the location of the object. Do you understood? So, first of all, we have to identify the forces. Okay. So, consider a book placed on a table. First of all, we have to find gravitational force. Gravitational force that is acting downwards on the book. Gravitational force that is acting downwards on the book. Second, another force that is a normal force exerted by the surface of the table on the book. You understood? So, there are two forces. Next, so according to Newton's third law, there are two reaction forces also. First of all, the book exerts an equal and opposite force on the earth, that is gravitational. Second, the normal force. Third, you have to draw the free body diagram. What is the free body diagram? See the picture. The center or point that is the book, and the normal force going upward and the gravitational force mg coming downward. So, here a book placed on the table. Here two forces are acting. One force is normal force exerted by the book, and another is the gravitational force acting downwards on the book. Have you understood, children? This is the free body diagram. Now, next application is particle moving in an inclined plane. Okay, particle moving in an inclined plane. So, when an object of mass m slide, on a frictionless surface, okay, on a frictionless surface with inclined angle theta as shown in the figure, okay. Theta is the angle, an object of mass m. Okay, see there is a object, okay, there is a object, a rectangular object, okay, the mass of that object is m. First of all, what are the forces acting on it, okay? First of all, we have to determine the acceleration of the object, and second, speed of the object when it reaches the bottom. Second off, we have to find the speed of the object when it reaches the bottom. Next, the force acting on the object, okay, downward gravitational force, okay, and the object ku or gravity irukum, that is mg, and the normal force, that is n. So, to draw the free body diagram, the block is assumed to a point mass m. So, the motion is on inclined surface. So, we have to choose a coordinate system. So, what is coordinate system? X, Y, Z axis. So, we have to draw it in the Z axis form. So, there is a derivation for it. Okay, I will explain you. Okay, in the further classes, okay, that is mg sin theta and mg cos theta. It is resolved into mg sin theta, mg cos theta. Okay, the final the value is v equal to root of 2gs sin theta. This is the value of the speed when it reaches the bottom. Next, motion of connected bodies. Okay, there is another important question, two bodies in contact on horizontal surface, okay, that is a important question, that is a derivation, okay, I will teach you in another class, okay, important derivations everyone I will teach you in the board, okay, right. Now, motion of connected bodies, okay, so see here in the picture, two blocks connected by a string, two blocks irukku, okay. Two blocks are there, one in blue color, one in yellow color, okay. Two blocks are connected by a string, a pulley, okay. There is a pulley and a string, okay. Right. Now, when the objects are connected by string, and a force is applied vertically or horizontally. Force is applied either vertically or horizontally along an inclined plane. So, it produces a tension in the spring. So, which affects the acceleration to an extent. So, let us discuss the various cases. First of all, in vertical motion what happens? In horizontal motion what happens? Okay. Two blocks irukanga. First avanga vertical motion la vecha avanga eppadi pandranga, next avanga horizontal motion la avanga rotate pandra eppadi irukkranga, like that we are going to see. First of all, in vertical motion, okay, consider two blocks of mass m1 and m2 by a light string and passes over a pulley as shown in the figure. So, let the tension of the string will be capital T. Tension is the capital T and acceleration is a small a. So, when the system is released, both the blocks start moving. So, m2 vertically upward and m1 downward with same acceleration. So, the gravitational force m1g on mass m1 is used in lifting the mass m2. So, now the upward direction is chosen as y direction. So, now we are going to apply Newton's second law for mass m2. Okay. So, what happened? Tension is Tj minus mass m2 and the g is the gravitation equal to m2 aj. So, like that. Further, for mass m1 and m2 we will get this equation, T minus m1g equal to minus ma. Ma is the second law. So, m1g minus T equal to ma. So, now adding both the equations, we will calculate the acceleration. So, acceleration can value is m1 minus m2 by m1 plus m2 into g. So, if both the masses are equal, that is acceleration equal to 0. That is acceleration equal to 0. Okay. Now, if m2, the mass m2 is greater than mass m1, okay. So, what happened? T minus m1g equal to m1a. So, a equal to T minus m1g by m1, okay, where acceleration is calculated. Now, we are going to equate the first equation and second equation, okay. We will find T equal to 2m1 m2 by m1 plus m2 into g, okay. This is the tension acting on the string. Tension அப்படிங்கிறது ஒரு force, okay. This is the tension acting on the string. In this way, it is in vertical motion. We can also find it in horizontal motion, okay. For horizontal motion, the tension of string will be T equal to m1 m2 by m1 plus m2 into g. The 2 will not come, that's all. In vertical motion, we are multiplying it with 2, but in horizontal motion, it is not multiplied with 2. That's all the difference, okay. The forces acting on the mass m2 is gravitational force m2g, normal force, horizontal tension, and the forces acting on mass m1 is gravitational force and tension only. So, there is a difference between this mass m1 and mass m2. Now, what is concurrent forces? What is concurrent forces? Okay, it is a very important question, okay. Concurrent forces, Lami's theorem, okay. There are many problems regarding this formula, okay. There is a problem, okay. Go through it, the problem is very important, okay. First of all, what is concurrent forces? Let me tell you, a collection of forces is said to be concurrent. Collection of forces if the lines of forces act at a common point, okay, act at a common point. See in the picture, F1 or force irukku, F2 or force, F3 or force, but 3 of them are acting at a common point O, common point O. Do you understand? So, a collection of forces is said to be concurrent. Collection of forces is said to be concurrent if the lines of forces act at a common point. So, the concurrent forces need not be in the same plane. Concurrent forces need not be in the same plane. So, if they are in the same plane, they are concurrent as well as coplanar forces. You understood? Concurrent forces need not be in the same plane. If they are in the same plane, they are concurrent as well as coplanar. Do you understood? See in the picture, there are 3 forces from different side, okay. It is called concurrent forces which is acting at one common point. If they are in the same plane, then it is called coplanar forces. Coplanar forces. This is the concurrent force. A collection of forces, okay, if the lines of forces act at a common point. What is Lami's theorem? Okay, what is Lami's theorem? So, if a system of 3 concurrent and coplanar forces are in equilibrium, okay, 3 forces irukka F1, F2, F3 are in equilibrium in same common point, okay. Now, Lami's theorem states that, the magnitude of each force of the system is, proportional to sine of the angle between the other 2 forces, is proportional to the sine of the angle between the other 2 forces. Do you understood? Lami's theorem states that magnitude of each force of the system proportional to sine of the angle between the other 2 forces. The constant of proportionality is same for all the 3 forces. Constant of proportionality is same for all the 3 forces. Now, let us consider 3 coplanar and concurrent forces. 3 coplanar and concurrent forces, that is F1, F2 and F3, which act at a common point O. So, if the point is at equilibrium, then according to Lami's theorem, what happens? See the picture. F1 first force எடுத்துக்கோங்க F1 அதுக்கு கீழே ஆப்போசிட்டில் என்ன ஆங்கிள் இருக்குது பீட்டா. F2 ஃபோர்ஸ் எடுத்துக்கோங்க அதுக்கு ஆப்போசிட்டில் என்ன இருக்குது தீட்டா. F3 ஃபோர்ஸ் எடுத்துக்கோங்க அதுக்கு ஆப்போசிட்டில் என்ன ஆங்கிள் இருக்குது ஆல்ஃபா. டு அண்டர்ஸ்டுட்? இதை வச்சு தான் ஈக்குவேஷன். ஸோ F1க்கு ஆப்போசிட் பீட்டாவா, ஸோ F1 by sin பீட்டா. புரியுதா? அப்போ F1 is directly proportional to sin beta. அப்போ F2 is directly proportional to sin theta. F3 is directly proportional to sin alpha அப்படின்னா வரும். ஸோ அந்த proportionality எடுத்துட்டோம் அப்படின்னா F1 by sin beta, F2 by sin theta equal to F3 by sin alpha. Do you understood? This is Lamis theorem. ஃபோர்ஸ்க்கு ஆப்போசிட்டில் இருக்கக்கூடிய ஆங்கிள் வந்து இதுக்கு ப்ரொபோஷனல், இதுக்கு ப்ரொபோஷனல். ஓகே, do you understood? Now, what is the application for Lamis theorem? இது எங்க அப்ளை பண்ணுவாங்க அப்படின்னா, a boy, okay, a baby boy is playing in a swing, okay, swing ஊஞ்சல், okay, which is hanging with the help of two identical chains at rest. Now, identify the forces acting on the baby, okay, see the example 3.14. So, here we are going to apply Lamis theorem and we are going to find the tension acting on the chain, okay. So, the boy is swinging. So, அது எப்படி Lamis theorem மாடலில் எழுதிக்கிறாங்க. That rigid support and the tension to அப்புறம் ஒரு gravitational force கீழே இழுக்குது. So, அதுக்குள்ள theta values we are applying. So, ஒரு gravitational force இருக்கு, ஒரு tension இருக்கு, ரெண்டு string இருக்கிறதுனால tension இருக்கு. So, அது எப்படி பிரிக்கிறாங்க theta, theta, t sin theta, t sin theta, 2t cos theta. Now, we are going to apply Lamis theorem. அப்போ first force by sin 180 minus theta, t by sin 180 minus theta equal to mg by sin 2 theta. In this way, we are calculating the Lamis theorem. So, Lamis theorem is applicable in many field. Okay. Now, conservation of linear momentum. Conservation of linear momentum. Okay. So, in nature, okay, in nature, the conservation laws plays a very important role, okay. That conservation laws plays a very important role. The dynamics of motion of bodies can be analyzed very effectively by using conservation laws. So, there are three conservation laws in mechanics. Three conservation laws. First of all, conservation of total energy. Conservation of total energy. Next, conservation of total linear momentum. Next, conservation of angular momentum. So, by combining Newton's second and third laws, we can derive the law of conservation of total linear momentum. You understood? By combining Newton's second and third laws, we can derive the law of conservation of total linear momentum. So, when two particles, okay, interact with each other, they exert equal and opposite forces. So, F21 equal to minus F12. Do you understood? First of all, what is the definition for momentum? Momentum equal to what? Mass into velocity. Isn't it? So, linear momentum is a vector quantity. Vector quantity because it determines both magnitude and direction. Magnitude and direction. Okay. So, P1 plus P2 is the total linear momentum of two particles. So, if there are no external forces acting on a system, then the total linear momentum of the system is always a constant vector. Always a constant vector. So, there is a collision, okay, there is a collision between two particles, one is at rest and one move towards other. So, first particle which is at rest, we will go towards other. So, they collide and after collision there is some changes. So, according to conservation of momentum, the total linear momentum after collision is in forward direction, So, we can write the Newton's second law in terms of momentum. So, dp by dt. P is the momentum, so change in momentum by change in time equal to d of mv. So, P equal to mv by dt. Next, m into dv by dt equal to dv by dt is acceleration, isn't it? So, ma. Next, dp by dt is what is the net force. So momentum is the force, kinetic energy is the work. So this is the conservation of linear momentum. Now what is impulse? What is impulse? Okay, what is the definition of impulse? Let me tell you. Okay, right. Impulse is defined to be the average force. Impulse is defined as the average force. Okay, F average times the length of application time. The length of application time, delta T. So the SI unit of impulse is now impulse is the change in momentum. Impulse is the change in momentum, that is I equal to FAV delta T equal to delta P equal to delta P. Okay, I will explain you clearly. Okay, what is impulse? What is impulse? First of all, if a very large force, okay, or a large force irukku, which is acting on an object, for a short duration, okay, large force, short duration, large force acting on an object for very short duration, then the force is called impulsive force. Okay, that is called impulsive force. Okay, see, impulsive force I equal to F average into delta T, that is delta P, that is delta P. Okay, I will give you some illustration, then you can understand it clearly what is impulse. See the examples. Okay, first example, when a cricket player, okay, when a cricket player catches the ball, he pulls his hand gradually. When the cricket player catches the ball, he pulls his hand gradually in the direction of the ball's motion, isn't it? Okay, when a cricket player catches a ball, he is catching a ball, he pulls his hand gradually in the direction of the ball's motion. Why? If he stops his hand soon after catching the ball comes to rest very quickly. So it means that the momentum of the ball is brought to rest very quickly. So the average force acting on the body will be very large. Average force acting on the body will be very large. So due to this large average force, the hands will get hurt. So to avoid getting hurt, the player brings the ball to rest slowly. Do you understood? So to avoid getting hurt, the player brings the ball to rest slowly. Next one, when a car meets with an accident, okay, its momentum reduces very drastically in a very short time. So this is very dangerous for the passenger inside the car, since they will experience a large force. Okay, or accident nadandana or large force act avum. Okay, so prevent this fatal shock, cars are designed with airbags. Cars are designed with airbags in such a way that when the car meets with an accident, the momentum of the passengers will reduce slowly, so that the average force acting on them will be smaller. Third one, okay, the shock absorber in two-wheeler, okay, play the same role in airbags in the car. Have you seen the shock absorbers in two-wheelers? So when there is a bump on the road, okay, when there is a bump, okay, what is a bump? Okay, that a sudden force is transferred to the vehicle. So the shock absorber prolongs the period of transfer of force onto the body of the rider. So vehicles without shock absorbers will harm the body due to this reason. So jumping on a concrete cemented floor is more dangerous than jumping on the sand. Have you experienced? Jumping on a concrete cement floor is more dangerous than jumping on a sand, because sand brings the body to rest slowly than the concrete floor, so that the average force experienced by the body will be lesser. Okay? Okay, I will ask you another question. If an egg is thrown, okay, if an egg is thrown, can you catch the egg safely without breaking it? ஒரு ball ஒரு egg தூக்கி வீசும்போது you are catching it, no? How you are catching? It is like the ball, because your focus is on the egg only. Your hands will be ready for that that power, okay, for ball, our hand should give more power to catch it, but for egg we will give the power according to it. So that is the impulse, a large force for a short duration. This is called impulse. Now, what is frictional force? What is frictional force? So, frictional forces is present everywhere in our daily life. Frictional force is present everywhere in our daily life. So, it is simply impossible to reduce it completely. So, it is very impossible to reduce the frictional force. So, what causes the frictional force? The causes of resistive forces of friction are molecular adhesion, surface roughness and flowing effect. So, adhesion is the molecular force resulting when two materials are brought into close contact with each other. So, if a very gentle force in the horizontal direction is given to an object at rest on the table, it does not move. It is because of the opposing force exerted by the surface on the object. So, this force is called frictional force, which always opposes the relative motion between an object and the surface where it is placed. So, if the force applied is increased, the object moves after a certain limit. So, there are two types of frictional force, static friction and kinetic friction. Static friction and kinetic friction. See a car, when the car is moving in a road, the car experiences a thrust force, okay, with air. Airukkum carukkum nadulla irukakudi and இதுதான் thrust force. ரோடுக்கும் டயருக்கும் இருக்கிறது reactive force, okay, and the weight to the road, that is gravitational force, and backside to that air, that is drag force. Now, what is static friction? Okay, static friction is the force which opposes the initiation of motion of an object. Initiation of motion of the object. Static friction is the force which opposes the initiation of motion of an object on the surface. So, when the object is at rest on the surface, only two forces act on it. So, they are the downward gravitational force and upward normal force. The resultant of these two forces on the object is zero. What is static force? Static frictional force, the friction that occurs when the objects are not moving. It is the friction that keeps objects in a place. See the picture in the table, there are pictures, isn't it? So, it is the friction that keeps the object in a certain place. When the objects are not moving, at that time static friction happens. Example, a boy sitting on the ground, your book sitting on the table, your backside against the chair. So, it are not moving, no, it is sitting in a same place. That is called static friction. Now, what is kinetic friction? Kinetic friction. This kinetic friction is sliding friction. Okay. It is a force that resists sliding or skidding motion between two surfaces. Okay. This kinetic friction is a sliding friction. Okay. It is a force that resists the sliding or resists the skidding motion between two surfaces. Okay. If an external force acts on the object which is greater than maximum static friction, the object begins to slide. So, when an object slides, the surface exerts a frictional force called kinetic friction. Do you understood? Now, what are the difference between static friction and kinetic friction? Okay. In static friction, it opposes the starting of motion. But kinetic friction, what happens? No, it opposes the relative motion of the object. Static friction opposes the starting motion. Kinetic friction opposes the relative motion. Now, the static friction is independent of surface of contact. Kinetic friction is independent of surface of contact. Okay, both are independent on the surface of contact. Next, mu s. mu depends on the nature of materials with mutual contact. Mu k depends upon the nature of materials and temperatures of the surface. Okay. Next, it depends upon the magnitude of applied force. Magnitude of applied force. Kinetic friction is independent of magnitude of applied force. Okay. It can take values from 0 to mu s n. It can never be 0 and always equal to mu k n. Okay. It is less than maximum value of static friction. Okay. And the coefficient of kinetic friction, mu s is the coefficient. Okay. Coefficient of less than coefficient of static friction. Here in static friction, the coefficient is greater than kinetic. But in kinetic friction, coefficient of kinetic is less than coefficient of static friction. Okay. Do you understood? Now, so to move an object, push is here is pull or easier. Push alladu pull. Which one is easy? This push and pull are opposite forces. Okay. This push and pull are opposite forces. So, when a body is pushed at an angle theta, the applied force can be resolved into two components, that is F sin theta, that is parallel to the surface, and F cos theta, that is perpendicular to the surface. Now, the total downward force acting on the body is mg plus F cos theta. Total downward force acting on the body is mg plus F cos theta. It implies that normal force acting on the body increases. So, there is no acceleration along the vertical direction. Now, normal force is equal to gravitational force plus F cos sin theta. So, we can come to a conclusion that it is easier to pull an object. It is easier to pull an object than to push. So, pull is easier one. If anyone asks push and pull, which is easier, you have to tell that pulling an object is easier. Pulling an object is easier than push. Now, angles of friction. Okay. What is the angles of friction? That is angle of repose. Okay. Angle of repose, that is a derivation question. Okay. I will teach you in further classes. Okay. Right. If the applied force P, okay, there is applied force P that has a horizontal component. Horizontal means x-axis, okay, Px, which tends to move the block. Now, the force will have a horizontal component and thus will form an angle pi, okay. So, with the normal to the surface, this value of angle is called static friction. Okay, these are the angle of friction. Okay, consider an inclined plane. Okay, consider an inclined plane on which object is placed. Okay, on which an object is placed. Okay, this angle of friction is noted. Angle of friction is noted. Okay, see the picture. There is an object. Okay, there is an object. There is a square object. Okay, that W is a weight. Okay, acting on it. There is a force. Okay, P அப்படிங்கற ஒரு force வருது triangular formல. கீழ இருந்து Rங்கற ஒரு force வருது. That is also triangular form. It is in an inclined form. Okay, so the forces is coming in inclined. So the angles are created by the friction. This is called the angles of friction. Okay children, that's all about today's class. Now, I am telling you the homeworks, okay. Write down 10 one words from the topic. Write down 10 one words from the topic, okay. Next, you have to write concurrent forces, okay. Draw the diagram and what is concurrent force and explain what is Lami's theorem and the formula for Lami's theorem, okay. Next, explain what is impulse, okay. What is impulse and the examples of impulse. And further, you have to study and go through the difference between static and kinetic friction. Static and kinetic friction, okay. 10 one words, write it in your homework note, okay. And concurrent forces, Lami's theorem, explain impulse, you write it in your classwork note, and the static and kinetic, you write it in your assignment. Static and kinetic, you write it in your assignment. Okay children, that's all about today's class. Thank you. Have a nice day. Stay home, stay safe and study well. Okay.